Yeah, so let's just copy all the assets from that we download to our project folder. In my case, emp25. Pointing to the folder of our project, yeah, the project that I create, just extracting everything. So aside from the things that we created last time, folders like animations, models, uh, some textures. So yeah, from here to extract it, the assets folder, yeah, from our product. Okay. As our field in getting a bit, there are a bit too many things. We will create a new scene. So we need to go to the scenes folder, right click to create scene. Yeah, and let's call it endless runner. In this scene, we want to open scene. Yeah. So double click it. Like to save the changes in the first scene that we do. And right now we've got new empty. So we will start by uh, creating some floor, and that will be or grounds that we will use. So once again, 3D object plane. Let's make it a bit wider so that we can see more of it in the game view. Now, for material folders, two new materials. One of them is ground. We can assign it to our plane so that it looks like ground. And we will be, during these classes, we will be moving that. And we will create a simple endless runner game. Okay, we've got our ground. We can also change the skybox. That is what you can see here. Yeah. Now that blue sky, we track dark sky material to our scene. It gets darker. So just drag it here. Now, have we done that? Okay. In the animations, you've got some human that will run. If you look at the inspector window, you can see the import settings of it. What interests us the most, the rig tab. We want to change the animation type. Right? And press apply. Then let's go to the animations tab, choose the run animation. We want to loop time, loop pause, and here we want to mark those two. If you are not sure, you can look uh, at the screen in the instruction. And having done that, we can press apply, so that now we've got applied those changes. And we will drag our character here and move him a bit to the front. So that we can see him. We can also change the orientation of main camera. Some adjustment in my screen also. So first of all, I will rotate that guy. Oh no, rotation is good, but I will move him a bit closer and also make the plane a bit longer. Okay. Now, uh, we want our guy to uh, run from the start, yeah? So to play animation of flying. So let's select this object, press Ctrl and 6 to open animation tab. Uh, oh, actually no. We will do it in this animation. Let's click and choose Create and Animator Controller. And let's name it Character Animation. Now double click, new tab will open, yeah. This is the tab to control some basic animation. Basically, the animation in Unity state based. So we've got enter state, exit state, and end state. Now, let's right click here and create state empty. As you can see from the entry state, there is a transition that's in state. Selected. You see that there is an function. Okay, so now we did everything right and click play. Oh, one thing that I forgot to say you, we need to drag this controller to the character because we created it, but yeah. So we've got a simple run animation right now, yeah? Okay, right now, you press play, the guy starts running and runs to the end, but we don't want him to run endlessly further from the camera. Yeah. So we need to uncheck here apply root motion. And now if we press play, do it by creating simple scripts that will change the texture that we have on our ground. Okay. So in the scripts folder, let's create a simple script, and let's call it texture scroller. Okay, let's open that. Okay, first of all, if we want to uh, affect only the texture that is added to the ground, we need to reference that specific instance of texture and, to be honest, the material. So first, we will create a reference to the renderer. So here we create use serialized field. Next, we will create reference to renderer. So protected renderer. Let's call it rend or renderer. Actually, your choice. Yeah. Next, we will create protected floats that will represent how much per second the texture will be scrolled. Yeah. So float, or it can be called scroll value. Okay. Scroll value or scroll speed would be also okay. So now the update method, we want to access the renderer. So rend. Next, we place and dot to access property of that renderer. In that case, the property will be the paired material. Next, main texture to get access to main texture offset. So no just main texture, but main texture offset. So way we can access the offset, but we need also the, so maybe here let's create serialized fields once more. Serialized fields that will be scroll speed. Scroll value will be current value. So scroll value will be main texture offset, and I think X, we will see in a moment, plus scroll speed times time delta time. Yeah, just like the last time when we were rotating cube, we need to make it independent of the amount of frames per second that we have. So here, thanks to that, we will have constant offsets, range of offsets basing on the scroll speed. And we need to assign that value. So once again, renderer, paired material, main texture offsets is through equals new vector 2 e. And now we will reference scroll value and 0 on the y. It's possible that we need to reference to the y-axis, but we will see in a moment. Yeah. Okay, so let's save it back to Unity. Okay. So now we've got this script. Let's assign it to our claim. Here in the rand field, want to reference the renderer that is at our plane. And scroll speed. Let's start with 0.5. Press play. We can see that we choose the wrong offset, yeah, because he's running and the texture should scroll that way, not this way. So, so here we want access the main texture offset X, but Y. Oh, sorry. So here Y instead of X, and here not scroll value and 0, but 0 and scroll value. Okay, saving, going. We see now that in our case, we can put minus 0.5. Spread by yourself, yeah, because it all depends on how you position your plane, yeah, what is the rotation, and so on. Okay, we are after some time we are getting pretty big values of the scroll value, and basically we don't want it. So we'll do one more adjustment here. We will add condition. So if scroll value is greater than 1 or scroll value is smaller than -1, then scroll value equals 0. Because we want to kind of cap it, the effect should be the same, but the scroll value won't go to the high amounts if the game will be running for a long time. Yeah. So I will just save it. And I'm just testing if that works. Oh, I forgot to change it to minus. Okay. Okay. Oh, what have I done wrong? Oh my god. Not and but or. Stupid mistake, but so once it's -1, it goes back to 0 because in general the offsets should be in that range, yeah, from 0 to 1 basically, or from 0 to or from -1 to 1. So that way we are clapping it. Okay. Okay, during the last classes, we added the cube collider to our objects. This time we want to add an capsule collider. This collider is represented by those green lines, but our character is not inside those lines, so we need to adjust it. So first of all, adjust the center position to about 0.85, high to about 1 meter 80, something like that, and the Z position to about -20. Yeah, we want our whole character to be inside that collider. Okay, so right now our character is moving, but he's just running in this one place, and we want to be able to move him in right or left direction. So let's create a simple script to control his position. So character controller. Okay, let's open up the Visual Studio. Okay, so uh, first of all, we need to define how much left or right he can move per second. So let's create a variable for that. So once again, serialized field, load can be private or protected if we want to derive from that. And let's call it. Okay, next. Or maybe we will do it later, another field, so you can see how it. Okay, so when we press the right arrow, okay, we want to move the character to the left. When we press the right, we want to move him to the right. When we press left, okay, we want to move him to the left. So we need to check the input from the keyboard, yeah? So once again, we create condition if input get k down k code, and our k code will be right arrow. So when player presses the right arrow key, yeah, we want to change our character transform. Yeah, we want to change his position. So transform position to equals to vector 3 graph speed. Yeah. So because we are changing the just the x-axis 0 0. Sorry, not equals but plus equals because we want to change it incrementally. Yeah. And if left arrow, we want to do it with the graph speed minus. after we after we save the code, let's assign it to the character. Let's ah, of course, what I've forgotten, graph speed times time delta time. Yeah? Because as we already done it a few times, we want it to be frame independent. Yeah, so constant value by second. Okay, so let's assign some strap value by example 2, and let's check that works. And why doesn't it work? Okay, it doesn't work. Well, it works, but not the way we expected, because the changes are minimal, because input get k down executed only on the first frame that we pressed k, yeah? So input get k, because it will be called as long as the k is pressed. So not get k down, just get k. Okay, it works, but as you can see, there can be a problem when I move the character out of the screen. So I need to stamp the X value somehow. Yeah? So I can see that now in the rightmost position, the character has X at 428, yeah? And at the maximum minus that he should be allowed is minus 4. Oh, maybe let's make it minus 428 also. So we need to stamp this value. So here in the update, we will once again access the transform and cap it. But to make it more flexible, let's define the variable that will say us what are the maximum and minimum values that are allowed. So protected, maybe make it a vector2, so that the x value will be minimum and the y value will be maximum value that is allowed. So vector2 min max x value. Okay, we don't want to call this method every frame because uh, this will be stupid. So we want to clamp that value only when either player press right or press left arrow. So we'll create a new void that will clamp x value. In this method, we want to get the transform position x. We are creating variable for that current value of x, and we are assigning the value of transform position x here. Next, we will say that we want to change that x current value to min max x and min max y. And later we need to assign that value. So transform position equals new vector3 x current transform position y because we don't want to change it, and transform position z because we also don't want to change it, and we can't just change the one part of the vector. Yeah. Okay. Now let's save it. As you can see, the min max value variable is exposed in the editor. So for x, I will just write minus 428 for y, and and what have I forgotten to do? I created voids, but forgot to call it. So inside those two conditions, we need to call that void to execute it, yeah, and to clamp those values. Okay. You may wonder why did I put the capsule collider on this character? I did it because we want to detect either the collisions or we want to detect that the player goes in some trigger zones. Yeah. So for now, let's just create the 3D object cube and let's place it here. So the character will, if we move him right, he will collide with it, but at least. And let's add an rigid body component to this box, to this. In this case, I don't want the player to charge the cube. Yeah, I want him just to get into the trigger zone of that element. So so we will unmark the use gravity and mark his kinematic. And now we will create another simple script that will, at the start, will inform us if the player has collided with or has entered this trigger zone. Oh, and most important, in box collider settings, we need to have the trigger. Yeah. So now, let's create the simple script that will be responsible for that interaction. Let's call it trigger zone base. Let's eat the start and update methods, and we will add a new method called interact. It may be protected. And we'll call this void when something enters the trigger zone. So to check if something has entered the trigger zone, we can use Unity function on trigger enter. This function method will be called when something enters the trigger collider trigger. Yeah. So it has information about other collider that entered, and in our case, we want to keep it simple, but let's make it protected for now. We want to keep it simple, so we will just call interact. Maybe in interact as an argument, we will send the other also. So we are basically calling our function interact. And right now, for the debug purposes, we will just use debug.log. And for now, we will just write other game object name. So each time something goes into the trigger zone, we will display name of that object. So here we have our console. Yeah, what I haven't done, I haven't assigned this script to the cube. So yeah, I keep on forgetting that thing, and I have to. Yeah, so I'm in trigger zone, and as you can see at the bottom, I've got uh, I've got the message that the something in that case our player uh, entered this area. Yeah. So that's basic detection of collision, or in this case, trigger enter. So we want to expand it a bit. So we will change our player controller character controller a bit, or maybe not. Maybe not. Okay. Maybe let's do it differently. Let's create another script that will be our game manager. As because we are creating just a simple game, so we don't have to worry about that there will be multiple game managers. Let's make it so that the game manager is a singleton. So first we need to create public static game manager instance. On start, let's make sure that the instance is now. We will create the serialized files for time left. So time left. Next, we will make. Let's make it a constant time reduction. So each time we enter some obstacle, we want to reduce the time. Yeah. So we need to know how much time we should reduce. So it will be time reduced. In update function, we will add that time left equals minus time delta time, so that the time will go down. If time left will be lower than 0, we will create for now placeholder function that will handle that. And we want to be able to inform game manager that he should reduce the time after the player collides with something. So let's create public void on time reduce, and it will be time left minus uh, minus plus time reduce. Okay, now in this group we use the trigger zone base, yeah, but we will derive from this class. So we will create new class that will be called obstacle. and we will derive from trigger zone base. Inside trigger zone base, we will change interact from protected void to protected virtual void so that we can override it in obstacle and make sure that we've got another function. So protected override void interact. And what we want to do, we want to call the game manager instance. We will use the null propagation to ensure that it exists. And we will call the function on time reduced. And what? Yeah, I haven't saved here, so didn't add the protected. Okay, now let's create empty objects that will be our game manager. And let's assign script time left for start, let's 420, 50 seconds, and reduce some, for example, 20. And one more thing, here in cube, as it will be our new obstacle, let's find the derived. So now the time is passing normally. When I enter, you can see that it was reduced by 20 seconds once again and once again. Yeah. Okay. So now we've got some game manager. We have a method to reduce time. Let's make it our obstacle prefab so that we can use it in different parts of our project. Now, uh, uh, now we want the obstacle to deactivate itself once the player hits. So once again, let's go back into our script and change it so that once interacted, the object turns off. Yeah. So we make game object set active false. This way, once we get into this cycle, the time will be reduced and the object will be deactivated. So once again, right? Yeah, it works. Now we've got obstacle. We can also create in similar fashion the power up. So let's create a new C# script that will be responsible for power up. It will also derive from the trigger zone base. And here we will also write a method to override method that will override override. Yeah. And in this case, we want to increase time. So game manager instance. And in game manager, we will need method. So once again, serialized files. Let's time bonus. Yeah, let's call it like that. And the public void on time left will be increased by time bonus. And in power up, we will call this method on time Next, we will create simple objects that will represent our power-up. It will be sphere. Let's move it here like that. That. Let's add a rigid body. Turn off the gravity. Make sure that it's kinematic. And let's assign power-up. If we look at the game manager, we set the time bonus. Okay, and back to the game. And what have I forgotten? Yeah, I forgotten to make it bigger. Once again, game manager. Yeah, works. Let's something less. Also 20. Okay, we will make prefab from the power up. Let's rename virtual power up. Now, we've got power up, we've got obstacle. Each of them either increases time or makes the time or reduces time. So now let's create pulling mechanism that will spawn our bullets, our power-ups or our obstacles, and also that we will make script that will move them across the plane, and when they reach zone, they will deactivate. Okay, so let's start with creating the object puller. Inside this class, we will create a class that defines our pool. It will contain public fields such as game object prefab, also public, or for the sake of for our sake, let's make it protected. Uh, let's make public tag that will public string, call it tag, or we can call it name, that will define our objects, and also initial pool size, also public of type int initial. Now, when inside object pooler we have class pool, we can create serialized files for list of the pools. And we can create dictionary that we will use to get pool. So k will be string, and value will be new of game objects. And let's scale it. Object. Okay, and now in the start method, we want to fill our object pools dictionary. For each pool in pools, let's define the two game objects. Next, we will uh, we will create object to the and add it to the queue. So int from 0 to initial pool size. We want to define game object bullet object associate pool prefab. Oh, it seems that pool want to enquire enqueue it, and later we want to set this object inactive so that active this object is active. We want to add it to the object pool dictionary, but string will be that pool tag, and whoever will be object. So yeah, that is filling of the dictionary of our queue. We will need to also add method to get object from pool. So public game object pool. Tag. Okay, and now we need to act. So here will be our key. Object plus object pool dictionary. I get value tag. Okay, and it will be game object. After we deploy, we want to activate the objects once again. So we will write the object from queue set active true. Next, we will once again enqueue it so that it goes to the back of the line. So now of object from queue, and we will return object from queue. If we don't find the right dictionary and right queue, we will just return null. So we will have to be careful about that. Okay, now let's go back to create object that will be responsible for that pool. So object pooler. Let's add the script. Let's define two pools. One will be for obstacle, and one for the power up and power up. Okay, now let's create a script that will spawn those items in our scene. So spawner Here we will make serial project that will reference for object puller, and we will create methods that will spawn an object. So public void spawn, like this. So we want to get okay, to be more precise, we will also a getter method public tool. Okay, so we make the puller random, puller, and so this way we will get a random tag from the pools. Yeah. Now having that tag, we will once again access the puller, tell the method for that object from the tag that we get now. And set we want to set the position of objects that we get. So we need uh, two vectors three that will define positions, or we can use it by reference. So maybe that way. So same objects. Oh, maybe now we have this item. We want to send position as vector 3 as max, and we will use the selecting value. We'll use random. Oh, of course here position. Okay, so this way the objects will be spawned. In our game manager, we can reference the object spawner. So let's make reference to And here in updates, if the time is above 0, we want to uh, spawn an object, but we need to define how often the spawning occurs. So let's define and about time, and we want to check if this is greater than time, and if so, want spawner random, and we have to reset the instance spawn. Okay, object with spawner. Let's make it so it spawns. Oh, well, anywhere. We will add our spawner script here, and we need to define reference to color, and we need to define two positions at which the objects will spawn. So uh, let's create an empty that will let's here, and another one here will be cost in. Now we'll uh, assign those two and reference owner our game manager. Oh, and here we need to set initial put. Let's say that an object spawn time maybe seconds. Let's see. So as you can see, we spawn an item right there, but it seems like moving fast. Let's move it both those game manager. Okay, so what's happening right now? Our object is being spawned, but uh, but 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 it is colliding with the ground, so it's getting deactivated. So let's object up, yeah, and now we can see that there is an obstacle, one, second one, yeah, and we spawn another one at the top, so they deactivated themselves. So now that we know that the objects are spawning, we can create simple scripts that will move the objects closer to the camera. That will be, in my case, the z-axis. So another script creates a script object mover. Okay, So now, in update function of simple script, want to transform uh, we want to translate it each frame by let's define here how much. So serialized field vector 3 amount. So we will move translate amount times time delta time. Okay, and let's add this script to the power obstacle and power up. So let's add it. So object mover. In my case, I think that we will translate it about 4 meters in. Let's check how it goes. Everything is great except that I should give -4 once again. And what have I forgotten to do? Of course, in the power up, the object should deactivate. Game object set active. Okay, so now once player touches them, I will make it faster that they move fast. Okay, in my case, that's fine. Well, although we need to look at how fast the texture is scrolling, so that it yeah too fast. So I, yeah, I think that's the best value that we can get. So yeah, right now we are moving our character. The character can gather power ups, but player won't see how much time he has left. So once again in our game manager, let's make time left as let's make getter method for time left. So public of time left. We we only want to get don't want anything else to be able to modify it. Now we will create simple UI that will display how much time is left and yeah. So let's start from the displaying how much time is. So we will create UI text macro. We need to import the essentials. We will select the text item, place it in the middle of screen. Next, we will write simple script that will get the time from the game manager and display it. So another C# script. Time save controller. Here we will reference text. So once again, serialized field text pro UI. Also display text. And in update function, and so game manager, and let's assign this script object, not this one. Let's reference it and send. Okay. To improve the visuals, we can format it a bit. Let's just and it looks a lot better. What else should we change? Well, right now the objects deactivate themselves only when they collide with tire. Uh, let's make here at the end also zone that will deactivate objects that will go there. So let's create group. Let's create that is. We can turn off the mesh renderer. Make it bigger and else add rigid body and create another simple script that will derive from the trigger zone base. So object deactivation zone right from base. Select the right by tract, and this time we will deactivate the objects that enter the zone. That way, once the objects, the power-ups will be here, they will be deactivated and they won't update their position. So if I collide with the obstacle, the time goes down. You see the obstacle. Oh, and what have I forgotten to do? I've forgotten to assign script to. So the cube goes there. Oh, yeah, the unmark use gravity mark is because right now the zone was spawning. We've got this power up, it got into cube, yeah, and it got deactivated. Right now, uh, when the cube interacts with power ups, they are uh, power ups for obstacle. The time still gets increased or decreased because because each collision has this effect. So we will make our trigger zone base a little bit different. We will define here the layers at which the object should call the function. So we will serialize fields, select the layer mask, and we will check. I haven't turned off the recording. So we will change the code that so that we will detect only the objects on specified layer. Yeah. Next, we need to ensure that the player is has its own layer. If you don't have the layer for player, you need to write it here. Now let's place the player on this layer. In the obstacle, let's change the detected player to player. The same in the power up. In case of both those objects, let's move them to the bullet object layer. And in this cube, we will detect bullet objects only. So yeah, now we are running. The object gets spawned. It collides with the this cube that destroys objects, but it doesn't affect time. So you can tweak with the settings with how fast the texture is scrolled, how often are the objects pulled, how fast do they move. You can display, try to display how much time is left, and also handle the case when the time is up and the game ends. Maybe display player some kind of message. You can do it using methods as shown in the time display controller. I mean by accessing the text property of something. So yeah, that's all for today. Thank you very much.